We can also apply Hess's law to calculate delta H of a reaction if delta H formation data is given. Before I look at this example, I'm going to give you a generic equation which is worthwhile remembering. If you have reactants producing products, which is always the case, and if you're challenged to as what is delta H of reaction when you go from reactants to products, we can use delta H formation, meaning if you have the elements that make up the reactants and products, elements make reactants, the same amount and same elements will make the products. So this pathway here can be known as delta H formation of products, and some of them because the coefficient is also involved, and this other pathway could be known as sum of delta H formation of reactants, which we assume you have the value. Now what happens is if you follow this route or pathway, you get to the products. Also, if you follow this pathway, you get to the products. So these two pathways or routes should equal to each other according to Hess's law. So route 1 equals route number 2. Now let's see what is route number 1, which is delta H formation of products, and route 2 is delta H reaction plus delta H formation of reactants. So I'm going to put them equal to each other, sum of delta H formation of reactants plus delta H of reaction is equal to root number 1, which is sum of delta H formation of products. I'm just going to write it in terms of delta H reaction. So this is an equation that you can remember, it always works. It's equal to sum of delta H formation of products minus sum of delta H formation of reactants. And then we are going to plug in our values. Let's just write the equation. This is reduction of iron trioxide. So you have Fe2O3 rust solid with carbon monoxide gas. It will give you element iron plus carbon dioxide. And I'm going to have 3 of this and 3 CO2s. Now let's just put delta H formation values that is given to us, all in kilojoules per mole, molar enthalpies. For iron oxide is minus 824, so I use this one. For carbon monoxide is 110 negative kilojoules, I used it. Fe, elements are 0 by definition. Delta H formation of elements are 0 because you are using the same element to make the element, therefore their delta H formation by definition is 0. Carbon dioxide is minus 393 kilojoules per mole, so I used it. Now let's just plug it into the equation. Delta H of this reaction simply is equal to products, which iron is 0, but you have 3 carbon dioxide, so 3 times minus 393, minus reactants, minus, you have 1 iron trioxide, minus 824, added to 3 carbon monoxide, which is 3 times minus 110. Once you plug all these numbers into a calculator, you are going to get minus 25 kilojoules per mole if I haven't made a mistake. So delta H of this reduction reaction is minus 25 kilojoules per mole. Then again, you can always use this, which is the end product of Hess's law, and a thermochemical cycle goes like this.